Okay, good evening. Welcome to
KidMath91.
KidMath91. This is fifth in our series and probably the last one on the area inside a parabola versus the area outside. And we're gonna do it. It's gonna be building up on everything we've done up to now, and we're gonna do it the same way. We're gonna look at a square, and we're gonna find out how much is inside, how much is outside, and then we're gonna let that size that square go to infinity. So because we have a parabola, if I pick a point x, I go up to a height of x squared. My parabola is y equals x squared. So that means I got to extend the square out a little bit to be x, to have a side that goes from really minus x squared to plus x squared.
Yeah.
Okay, so this distance out here is x squared, and then we have a height of x squared.
Yeah.
In the last video, KidMath90, we learned that this area underneath the parabola and above the x-axis, which I'll call area 1,
is 3x. I mean, x cubed minus 3. X cubed over 3.
X cubed over 3, right? And we're going to learn that eventually in calculus, but that's going to have to wait until you're older than 10. Okay? This rectangle here that's x wide and x squared tall, what's the area of that?
It's x wide by x squared.
Yeah, x wide, x squared tall.
It's
so the
x
area,
cubed.
it's x cubed. And this bit's x cubed over 3. So what's this bit here that I'm going to call 2?
So 2 is 2x cubed over 3.
Okay, awesome. This area here, which I'm going to call 3, is a rectangle that's x squared minus x wide. It starts at x and it goes out to x squared.
Yeah, and
And it's x squared tall, so what's its area?
So it's x to the 4th minus x cubed.
Very good. The length times the width. And down here I have a square that's x squared by x squared. So what's its area?
X to the 4th.
Okay. Okay, so my area, and now notice over here I've got exactly the same thing by symmetry.
Yeah.
So the area, the ratio of the area inside to outside, I can just look at this bit over here that we just calculated because this bit's going to be the same.
So
Okay.
the inside is just number 2.
The inside's just number 2. 2x cubed over 3.
So we have to add x cubed over 3 plus x to the 4th minus x cubed
Okay.
plus x to the 4th.
Okay, right. And you may have gone off camera there, so I'm going to erase half of my parabola here that we're ignoring and say the area that's inside is 2x cubed over 3. And the area outside is x cubed over 3 plus x to the 4th plus x to the 4th minus x cubed. So I get 2x to the 4th. I get x cubed over 3 minus x cubed. What's that?
X cubed over 3 minus x cubed is negative 2x cubed over 3.
Over 3. And now I'm going to take the ratio of these.
Alright.
Okay? Boom. So the first thing to do is probably get rid of the fractions of 3. Let's multiply the top and the bottom by 3.
Yeah.
So I get 2x cubed on the top. And what do I get on the bottom when I multiply the bottom by 3?
Well, you get 6x to the 4th minus 2x cubed.
6x to the 4th minus 2x cubed. Now notice I can factor out of the bottom a 2x cubed. You see that?
Yeah.
So I get 2x cubed on the top over 2x cubed times what?
Minus 6x to the 4th.
What do I get when I factor this 2x cubed out of this?
Oh. You get 3x. It's 3x.
3x.
And then you just have minus 1.
Minus 1. Very good. So these cancel, and I get my ratio is 1 over 3x minus 1. So it turned out to be a pretty simple ratio.
Yeah.
Okay, now, but the problem is,
When we get
that's only for whatever value of x I've picked here.
finite, yeah.
Okay,
But
now what happens when x gets really large? What happens to this ratio?
Well, it gets smaller and smaller and smaller.
It gets smaller and smaller and smaller. In fact, what number is it tending towards as x gets really large?
0.
It's almost 0, right?
Yeah.
So the ratio inside the parabola to outside the parabola starts getting closer and closer to 0.
But what happens when you get to infinity?
What happens when you get to infinity? Well, you have something that's getting, like, here's 0. You have something, if you plotted the points, here's x going this way. This coming this way, it's going down, 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 closer and closer and closer and closer to 0.
Yeah.
So it looks like, and this is a weird concept, right?
Yeah.
This infinite area here, compared to the area outside the parabola, it
Yeah.
starts looking like it's 0% of the overall area, even though it's infinite.
Weird.
Yeah, really weird,
Because
right?
both areas equal infinity.
Right, both areas are infinitely big.
But this one's 0%. That's
Maybe.
weird.
So it's a pretty small piece of the overall plane, what's inside the parabola.
Yeah.
Yeah, is that pretty surprising?
Yeah.
That is pretty surprising. Now, I should say this. Calculating ratios of things that are infinite is actually pretty difficult. And there's lots of paradoxes. And there's one called Russell's, I think it's called Russell's paradox, which is incredibly cool. And so there's a lot of different ways to think about this. So I just wanted to point that out. But here, I just wanted to show you this one way, to think of a square getting larger and larger and looking at the ratio of the area inside to outside.
Yeah.
And when we did that, we got a very simple expression. And it showed us that this infinite area divided by this infinite area got closer and closer to 0.
Cool.
It's a really surprising result, but it's cool. And I'm really glad you asked me this question last week, I guess. Because that's a cool question. It's really fun to think about.
Right.
Good job, man. Very good job.